All right. Today, we are jumping into one of the tougher lessons in calculus. It's not really tough. It's just so weird that it makes it seem more difficult than it is. Okay? This is the hardest lesson left. The good news is on Friday, after Friday, I'm not teaching you anything new. Okay? Friday is the last day of new notes for the entire year. We'll get new notes today, Wednesday, Thursday, and Friday, and all of them are pretty much very similar to each other. Okay, so each day we're going to do very similar stuff. Today's the hard day of the week. Everything else gets easier after today, I would say. But then we're done with new stuff at that point. Okay, so keep that in mind as we work through it. I'm asking you, how could you find the volume of this football? I gave you a little table down here. It starts at 0, so that's like down here on the tip of the football. Here is 0. There is 0. It goes all the way to 30. Talk with your neighbor for a second. How could we find the volume of this football, knowing we're going from 0 to 30 with different distances and then some diameters? The other number is the diameter. Talk with your neighbor. See what you can do. There we go. Thoughts on how we could find the area or the volume of this football? What could we do? Awesome. It's similar to that. Yeah, so he said LRAM or RRAM, which was finding some area and then adding them up. Kind of makes sense. So imagine what we're doing here. We're going to take this football and we're going to slice it. Okay. If I slice this right here and I just took this little section out. Okay. So I cut it and I held it and I showed it to you. What shape would it be? You would see a circle on the end, correct? Okay. Same thing. If I cut it right here, what shape would you see? A circle. How would it be different? It'd be smaller. The shape of the circle changes throughout. But each time, you would just have a circle, okay? If you found the area of each circle, okay, and cut this thing so thin that it didn't really matter. So like just a single little baby slice and a little baby slice. And I took all of those areas and I added them up. That would tell me the volume of the whole shape, okay? You take the area with the depth, but we're going to make the depth of that little cut so small that it's not going to matter. If we add them all together, it will tell me the volume of this different looking shape. Okay, that's going to be what we're trying to do today. It's a little bit strange, but again, I'm telling you, you have 4 new days of material. Today is the toughest. If you can understand today, the rest of this is pretty easy. Yes, sir.
Why can't you cut it long ways and then multiply by 360?
Cut it long ways. So the question was, could we spin it a different way to get the same area? Yes, and we will do that as we go. Here we go. Okay, looking at notes, that first thing is just describing what I just told to you. We're going to cut stuff different ways and get some different shapes. Here we go. Example 1, we are finding volume. The key to finding volume is integrating the area. Remember what integrating does. Integrating adds up all the different values. So we're going to integrate area because it's going to add up all the areas to get volume. The solid lies between planes perpendicular to the x-axis at x equals 0 and x equals 4. So x equals 0 is right here. X equals 4 is right there. The cross sections perpendicular to the x-axis are squares with base edges in the xy plane formed by these two lines. Find the volume. Okay, so let's start off by graphing these two things. Y equals square root of x. We can graph that. Up 1 over 1, up 1 over 3, and so on. Boom. There's that guy. And then y equals negative square root of x. What's going to be different about negative square root of x? It's just upside down. So we're starting here, there, there. It's going to get me that shape right there. Okay, so just like before, we're going to deal with this area. Okay, we've got this little guy right here. This is what's the enclosed region. We are drawing perpendicular to the x-axis. Show me with your arm. What does perpendicular to the x-axis look like? This is perpendicular to the x-axis. So we are drawing lines this way. Okay? So we're drawing lines that way. And it's going to make a square. Okay? It's going to make a square. I am really bad at drawing 3D shapes. So I'm going to rely on a computer program to show you what we're trying to do here. All right? So we got that base, and then we are going to have a square built from it. Here's what you got. Okay, here's our shape that you have drawn on our picture. We've got this different line that we're going to deal with. Okay, what it ends up doing over here is we are going to be able to make a square. Okay, let me adjust this number right here. All right, here we go. So as we look at this thing, we've got this line right here. Okay, and what we're going to do is we're going to be able to find different squares as we work across. Okay, from 0 all the way to 4. Okay, we've got squares being drawn over here. See how that shape is a square? Notice that at different lengths, the square is different sizes. Okay, it's different sizes as we go. Our job is to find the volume of that shape right there. See how it's different shapes as we go? The base is right there. It gives us different things. Everybody kind of understand what that shape is going to look like? It's weird. Let's do it anyways. Okay. So the key to anything we're doing today, to find volume, you integrate area. Okay, so we're going to integrate. The key to our integration here is going to be to figure out what our area is. We're going to integrate our area. If we're drawing vertical lines that are perpendicular to the x-axis, is this a dx problem or a dy problem? This is a dx. If you cross the x-axis, that's a dx problem. Okay, we've talked about that already, but this is a dx problem. From when until when am I going to draw the lines on the x-axis? 0 to 4, because that's the shaded region from 0 to 4. That's my enclosed base. The thing I need to know is I need to know the area of my cross section. What is my cross section that I'm making here? A square, right? Area of a square. What is the formula for the area of a square? Base times height. But what's special about a square? They're the same. So instead of base times height, which works perfectly well, we could just do side squared. Side squared. That's what we're going to integrate. Okay? We are going to take something and we're going to square it. The only thing we need to figure out is what is that something? In this case, what is that side equal to? Okay, so think about that picture we just looked at. This is what's happening. We're getting these squares like this. Oh, that looks terrible. Oh no, then I erased everything. But it's hard to draw 3D, but I think you kind of see what's happening here. You're getting these squares that are happening. They're going to stack along. When did I make the base of that square? From when to when? Top to bottom. From yellow to green. Everybody agree with me on that? We went boom right there. Boom right. That's the base. So we went top to bottom. So what did we do? We went from square root of x, top, minus the bottom. So it's top. That's this guy. Minus the bottom. That's that guy. Negative square root of x. What is square root of x minus a negative square root of x going to get me? Minus a negative, it's really plus. You have one square root of x, and then you got another square root of x. How many you got? S equals 2 square root of x. That is my side length. That is what goes in right there. All right, let me talk through it again. So we started off, we drew our picture. We found the bounded region. We said we were perpendicular to the x-axis, so that made this a dx problem. Our bounds went from 0 until 4. That's the x values that we use, 0 to 4. And then we figured out what was our cross section. Well, it's a square, which is side squared. And how did I draw my sides? From top to bottom, from top to bottom. I plug it in. Okay. At this point, you could use your calculator and get an answer. This one's easier to do without a calculator, believe it or not. What is 2 squared going to get me? 4. What is square root of x squared going to get me? X. I'm integrating that from 0 to 4 dx. What is the antiderivative of 4x? So I add 1 to my exponent. Divide by my new exponent. 2x squared. I'm plugging in 0 and 4. If I plug in 4, 4 squared is going to be 16 times 2 is 32. Then I minus my lower bound, which would get me 0. My answer is 32. If you don't believe me, type it into your calculator. Questions on how we did it? Yes, sir.
So is that the volume?
That is the volume of this crazy shape. Okay, when I figure out this thing all the way from 0 to 4, that is the volume of that thing right there. We do not need a unit when we do these types of questions. Good question. Anything else? It's weird. All we're going to do today is a lot of practice. It's going to be me walking you through a bunch of them because you need it. Let's go to the next one. 32. The solid lies between the planes perpendicular to the x-axis. The cross sections are rectangles whose height is 5 and base runs from the semicircle, this guy right here, to the semicircle, that guy right there. Find the volume of the solid. Here they were nice and told me that these shapes were semicircles, but we should know that already. We did that back in January. It's been a while. It's a semicircle. What would the radius of that semicircle be? It's 1. Like what if they gave me this right here? What would the radius of the semicircle be? 2. What if I gave you this right here? 3, and so on. Okay, we did that before. You've forgotten. Remind yourself. So this is just the semicircle. We're going to go a radius of 1. So I'm going to draw that right there. And then what about the negative square root? What's that going to do? It's going to be the bottom half of that circle. So I'm going to cheat here. Boom. There's that. And then this guy right here is the bottom half. So that's this part of the shape. Okay, because it's negative, it's going to take me to the bottom. Okay, so here's my shaded region. It's this guy. This is the shape enclosed by my figure. We are perpendicular to the x-axis. Show me with your arm. What does perpendicular to the x-axis look like? This. So I'm drawing lines that go like this. Cool. What is the shape that I am making when I do that? What are my cross sections going to be? Rectangles. So imagine what this looks like. You've got a base that's going to become a rectangle with a height of 5. And then you would have another one here that'd be big and a little one there. Okay, and so, again, I want to show you the picture of it so we can see what it looks like. Here we go. So look, again, here's my semicircle. Okay, we've got these. Now, I couldn't really draw rectangles, but you can see the squares that are being formed as we do this. Okay, it's going to look like that as we work our way across. Okay, the only difference between our shape and this shape is the height is always going to be 5. Okay, so it's going to go up to 5 each time. What shape is it going to make if the height is always the same? It'd be a cylinder. You basically are just making a cylinder here. All right, let's do it. So we're integrating. That's how you find volume. How do you find volume? You integrate area. We need to figure out what the area of our cross sections are. If we're perpendicular to the x-axis, is this a dx or a dy problem? It is a dx problem, correct. From where until where? Again, I'm talking x values because it's a dx problem. These right here need to be x values. What are show me with your fingers, what are your 2 x values going to be? My x values go from this x value right here, -1, to this x value right there, which is +1. The only other thing I need is I need the area. This is the area of my cross sections. Well, again, we said my area of, in this case, it's going to be a rectangle. That is my cross section. I'm making rectangles. What is the formula to find the area of a rectangle? Base times height. Is there anything we know in this case? The height, it's what? 5. And so all I need to integrate here is 5 times whatever my base is. That's what I need. If I know what my base is, I plug it in and I solve it. So in this problem, I need to figure out the base of my rectangle. What is it? Well, to make the base runs from the one semicircle to the other. So we are going from here to here. That is the base of my shape. So my base is going to be equal to what? What do I have to do to find it? Top circle minus bottom circle. So my top circle is this guy right here. Square root of 1 minus x squared. Top minus the bottom minus a negative square root of 1 minus x squared. It's minus a negative, so it's really positive. I've got 1 minus x squared, and I got another 1 minus x squared. I put them together, I now have 2 square root of 1 minus x squared. That is what's going to go in right there. Break out your calculator, type it in. Make sure you get used to typing it in. That's the tougher part of the day, is typing it in. Go. Make sure you can type it in. We're going second. No, we're not. We're going math. 9. We're integrating from -1 to 1. My formula is 5 base times height. My height is 2, or my base is 2, square root of 1 minus x squared. You type it in. You got a whole lot of parentheses going on here. It'll get a little bit more confusing as we go. We type it in. We hit enter. We get an answer of 15.708. Yes, ma'am. You can. You can use the letter Y, or you can just replace all the Y's with the letter X. Both ways will work. We good? Let's go to example 3. On example 3, it says find the volume of the solid. If the cross sections are semicircles perpendicular to the x-axis with the diameter in the xy plane. A little bit weird. Okay, the solid lies between the lines x squared minus x. Obviously, that's this guy right here. And y equals x. That's this guy right here. Obviously, we have that shape. We're perpendicular to the x-axis. So this is the enclosed region. I'm going perpendicular to the x-axis, so I've got this guy right here. And what's my shape going to be as I'm perpendicular to the x-axis? A semicircle. You got to look at it. There it is, semicircle. So I'm making these little baby semicircles that kind of work here. In the end, it's going to kind of look like a croissant. Okay, it's got a flat bottom when you cook it, but on top it's nice and pillowy and soft. Yeah, that's what's happening here. Okay, you're making a croissant. See if you can set up the integral. Okay, it's a little bit strange. The key to this is one that students miss all the time, but they're telling you the diameter. And when you find the area of a shape, normally you use the radius. See if you can do it. Talk with your neighbor. Here we go. Here's your shape. It looks like this. We drew our vertical lines, and when we look at it sideways, we're getting those semicircles. Okay, it's a croissant, or maybe like a cocoon that was built on a wall, so it's flat on one side. But that's the general shape that we're making here. Again, that's a really strange concept, but you don't have to be an expert at it to set this thing up. Okay, how do I find volume? By integrating area. Okay, so I got to integrate whatever my area is. As I set this thing up, we determined that we're perpendicular to the x-axis. So if we're perpendicular to the x-axis, is this a dx or dy problem? Dx. From what x value to what x value are we going to integrate? 0 to 2. The only thing I have left is area. Okay, this time we are finding the area of a semicircle. The area of a circle is pi r squared. You got to know that. We're going to do it 10 billion times in this chapter. Okay, pi r squared. But I don't want a circle. I want a semicircle. What else do I need to do? Throw a half in front. Okay, so the thing I'm integrating is 1/2 pi something squared. The only thing I need to do here is find the radius. From when until when did I draw the radius of this graph? From top to bottom, right? X, I drew it from here to there, from there to there. So it's x minus, and then in parentheses, x squared minus x. Now, what's the problem with that? What does that actually tell me? That tells me the diameter. I don't want the diameter. I want the radius. So what else do I need to do with that thing? Divide it by 2. Cut it in half. Okay? This looks kind of ugly, so I'm going to clean it up. I'm going to distribute that negative. So it's 1/2. X, it's going to be minus a negative x. So that's going to become plus, 1/2. X plus another x is 2x. And then plus x squared. That is my radius, 1/2. 2x plus x squared. 1/2 2x plus x squared. There's a whole lot of parentheses there. A lot of places you could make a mistake. Type it into your calculator. See if you can get an answer. Sorry, when I distribute that negative, I changed the sign. It is a minus x squared. This just became minus a negative is plus. My bad. Thanks. So as we type it in, we go math 9. We integrate this thing from 0 to 2. And then it's 1/2 pi r squared. So we're going parentheses. And then our radius is 1/2. And then another set of parentheses. And then negative x squared plus 2x. I know I just kind of flipped that, but that's okay. And then I got to close those parentheses. And I got to square that. And then I got to go dx. I type it in. I hit enter. I get 0.419 is the correct answer. If you look at that, there's a whole lot of parentheses and a very simple way to make mistakes here. Okay, here's my suggestion. If you get a complicated radius or a complicated anything like this, like the stuff in blue here, that's weird. The easiest way to do that is go to your y equals and type it in as your y equals. So we can type in our radius of 1/2 and then the parentheses that 2x minus x squared. Okay, just typing it in there now is going to make this a lot easier to type in. So now when I do math 9, I'm integrating from 0 to 2. It's easier to talk your way through it as well. You don't get confused by the parentheses. 1/2 pi, and then r is y1 squared. Notice the lack of parentheses that we had before. It's a lot easier to type in. I hit enter. I get the same thing. Okay, so when in doubt, if it's getting a little complicated, like this whole part is just your radius, type that in as y1, and it's going to be a lot easier to set up. Questions there? Make sure you're rounding to 3 decimals, 0.419. Last one. Find the volume of the solid. If the cross sections are isosceles triangles whose base is perpendicular to the y-axis, the solid lies between x squared plus y squared equals 9. Okay. Again, know that today is me working you through with every problem. Okay. Tomorrow you're going to be able to work more on your own pace, but today I just need to help you. Okay. What shape is this right here? X squared plus y squared equals 9. That is a circle. What's the radius going to be? It is 3. It is a circle with a radius of 3. That's something you need to know. We got my circle. Cool. We are trying to find volume. So if we're finding volume, we're going to integrate the area. We are perpendicular to the y-axis. Show me with your arm. What does perpendicular to the y-axis look like? This guy. We're drawing shapes now this way. Okay, we're going that direction as we set this thing up. What does that change about my problem? It is a dy problem. That's very important to understand. Okay, it's dy. So that means my bounds need to be y values. What are the y values that we're using as we stack these shapes? -3 to 3, from there to there. Okay, we are drawing isosceles right triangles whose base is in the diameter of this circle. Okay, so imagine that this is happening. As we draw a cross, we're going to have a triangle here. Okay, we're going to have a triangle like that that's going to be formed. It's a strange looking shape. Let me pull it up. This is my shape. So see that isosceles right triangle? It's going like this. The further back you go, the different the shape's going to look like. It's going to look like a circle on top, but it's kind of like this weird looking thing. But that's what we're describing. Okay, you could draw a right triangle right there. It's a party hat that's been sat on a couple times, but that's the idea. Okay, so we got to find the area of our shape. Okay, what is our cross section going to be? We're finding the area of a what? Triangle. Okay, and you got to be careful with triangles because sometimes they can be mean to us here. But this triangle, how do you find the area of a right triangle? 1/2 base times height. It's isosceles, so what's going to be true about the base and the height? They are the same. Isosceles triangles, remember, two legs are the same. In this case, the base and the height are the same. So it's 1/2 base squared. So I need to integrate 1/2 base squared. I'm integrating 1/2 base squared, where all I need to do is figure out what the base of my triangle is. Now think about this. From which line, from what side to what side am I going to find my base? Not top to bottom anymore. Right to left, right? Because we did this. We drew our lines perpendicular to the y-axis. So it's right to left. What's the problem with doing that here? It's the same thing. Okay? So what we need to do here, the other thing we got to do is, hey, it's a dy problem. So if it's a dy problem, I need to get this in terms of y, which means I got to get x by itself. So let's do that. If I get x by itself, I'm going to subtract that y squared. And then I'm going to get rid of the square by square rooting. I get x is equal to the square root of 9 minus y squared. What else do I need to do when I take a square root? Plus or minus, which is good in this case because I need two sides. This side right here, the right side, is going to be the positive 9 minus y squared side. Okay, it's the right side because it's in terms of y. This side over here is the negative square root of 9 minus y squared side. So when I set up my base, I drew it perpendicular to the y-axis, so I'm going from right to left. So my right line is the square root of 9 minus y squared minus the left side. The left side is a negative square root of 9 minus y squared. A minus and a negative, so it's really plus. I've got 1, I got another, so it's really 2 square root of 9 minus y squared. That is my base. That's what goes inside the parentheses. Now all I got to do is type it in. Take a second and type that in. Typing it in, we're going from -3 to 3. This is a dy problem, but you can just use dx and it works just the same. Okay, so you don't have to get worried about that. But -3 to 3, my formula was 1/2. And then its base, my base in this case is 2 square root of 9 minus y squared, but I'm just going to use x squared. It does the same thing. Close those parentheses. I got to square that dx. Throw that at the end, or again, you could have done with y's and got the same answer. I got 72. Okay, if you don't like that, then type in this part right here as y1. You'll get the same answer. Questions on something we did? It's challenging, but if you can get started on this, then the rest of the week is easy.